أنا باخد يلا نشوف كيف باخد البرامج نشوف. آه. آه. Now, let's go to the whiteboard. I will show you something. العفو. Real time. Landscape. Full screen. Okay. Now, assume that you are going to determine the Z transformation for cosine omega naught n only, no more. Look, cosine, example, find Z transformation for x of n equals to cosine n omega naught, sorry, without t, cosine n omega naught or omega naught n. What we are going to do in this example, first of all, I have told you we are going to apply the Euler identity. So it will be 1 over 2 e to the j omega naught n plus e to the minus j omega naught n again. Now, it will be two terms. Well, 1 over 2 e to the j omega naught raised to power n plus 1 over 2 e to the minus j omega naught again raised to power n. Now, the Z transformation for this one will be very simple and easy. 1 over 2 Z over Z minus e to the j omega naught plus Z over Z minus e to the minus j omega naught. Now, what about the ROC? Can anyone tell me what will be the value of the ROC? What is the ROC? What will be the ROC? Can anyone tell me what will be the value of ROC or not? Of course, in this time, A will be e to the j omega naught, okay, or e to minus j omega naught, the same. And when we're talking about the region of convergence, we have magnitude of Z greater than something, okay, greater than A. But in this time, we have A e to the j omega naught. What will be the magnitude for the e to the j omega naught? Array magnitude chanda for omega j naught. What will be the magnitude for e to the j omega naught? أري جماعات.
أنا infinity يا سيدة. Infinity.
Infinity. Another one. Are you awake or you are out of coverage area? Magnitude of e to the j omega naught. Magnitude of e to the j omega naught. Chanda.
دكتور منى إيكا.
عفرم إيكا. It is 1. Look. This is a vector. Magnitude 1 and e to the j omega naught is what? Is an angle. Okay. So its magnitude will be 1. So for such a case, the region of convergence has a magnitude be greater than 1. Okay. Now, going back to the slides. Now, in the slides, by now we can explain what's going on. Look, please. Now, the cosine signal is multiplied by what? By r to power n. So the magnitude is coming from what? From r. Without r, the magnitude is 1. With r, the magnitude becomes what? Becomes r. So the region of convergence, magnitude of z becomes what? R greater than r. Well, sorry, z greater than r. Another important property of the Z transformation again is what? Is the multiplication by n. Okay, multiplication by n. Of course, if we are going to multiply the signal by n, this will lead to what? This will lead to the derivation in frequency or in the z domain. So if we have nx of n, it will be minus dx of z by dz minus dx of z by dz. Of course, this is a very important property, and we may have such a case, I mean, nx of n. Now, let us discuss a case by which we have, for example, n multiplied by x of n. Simple case, very simple case. Let us go to the whiteboard, and then I'm going to solve this example in detail. What do you mean by this example? Yes. Yeah. Now, let us solve this example. Find the Z transformation for the following nu of n. Okay, nu of n. So what we are going to do for this case, whenever you see n is multiplied by a function, directly we are going to apply this formula minus z dx of z by dz. So look please, n, this is the property, important property, n multiplied by x of n, z transformation will be what? Minus z dx of z by dz. Okay, minus z dx of z by dz. Now, the z transformation for u of n, as you know, will be z over z minus 1, and the region of convergence magnitude of z is greater than 1. Now, due to multiplication of n, what we are going to do, first of all, we are going to determine the differentiation of x of z, and then we are going to multiply this term by minus z. Okay? Now, so you are going to what? You are going to find out the differentiation of dx of z by dz. Have I dipped the chant? Z minus 1 multiplied by differentiation of z will be 1 minus z multiplied by 1 divided by what? Divided by z minus 1 all squared. Okay? Denominator multiplied by the derivation of the numerator minus numerator multiplied by the derivation of the denominator over denominator squared. So it will be z minus 1 minus z over z minus 1 all squared. Okay? Now z with z will be cancelled, and the remaining will be minus 1 over z minus 1 all squared. Well, this will be the derivation of dx of z by dz. Now, the z transformation for nu of n will be minus z dx of z by dz, and in this time we have minus z multiplied by minus 1 divided by z minus 1 all squared, and it will be z over z minus 1 squared. Okay, really, this is the z transformation for nu of n. We have applied the property of what? The property of the derivation. Well, when we are going to when a function is multiplied by n, at that time the z transformation will be what? will be minus z dx of z by dz, exactly what I have done in this example. Well, now go back to the slides and to see what's going on. Now, really to understand this example, you have to give me your attention. Example, we want the inverse z transformation of x of z log 1 plus a z2 minus 1. This is a tricky example, really. This will be a tricky example, and to solve this example, you have to use the derivation property. Now, when we talk about log or len, they are the same, okay? With what? With some the differentiation, the difference in what? In the bases. Now, log or len the same. Can anyone tell me the derivation of len x? Can you derive len x? Len x, the derivation of len x will be what? Len x. Have you heard
1
about
over
it
x?
or not? Huh?
It's 1 over x.
Is 1 over x. Yes, it will be 1 over x. So by inspection, by any method you are going to do, for example, to determine inverse for this function, it will be very difficult. We don't have, for example, a signal which leads to log 1 plus az to minus 1 from in the table, of course. So you are given only two ways to determine the inverse for such a function. Either I'm going to use a tricky way as this solution in this example, or you are going to use what? As I think you have studied the Maclaurin series, power series, and so on. So you are going to expand this log into what? Into, for example, Maclaurin series, and then applying the inverse Z transformation, as we have said in the power series inverse. If we are going to find out a closed form, then we are going to follow this approach. Look, please. First of all, to get rid of from the log, I'm going to what? I'm going to derive x of z. So dx of z by dz will be 1 over 1 plus az to minus 1, okay? We said that the derivation of len of x will be 1 over x. Here, this brackets represents the x. So it will be 1 over 1 plus az to minus 1. Look, now, inside the bracket, we have a dx. It will be dx over x. So d of this brace will be what? For the constant, 1 will be 0, plus a z to minus 1. This minus 1 will becomes here and reducing the exponent by 1 again. So it will be minus a z to minus 2. This will be what? This will be the derivation of this number. Now, if we are going to multiply the both sides of this equation, multiply the both sides of this equation by minus z, what will happen? This becomes minus z dx of z by dz, and this one will be as follows, okay? Multiplying the both sides of this equation, I mean this one, by what? By z. Look, minus z dx of z by dz, and this one again multiplied by minus z. Minus with minus will be removed, and z to minus 2 becomes z to minus 1. Okay, now it will be a z to minus 1, 1 over 1 plus a z to minus 1. Now, if I'm going to ask you to determine the inverse for the right side sequence, it's very easy. Look, without z to minus 1, it will be z over z minus a. Okay? Z over z plus a, for example, or minus, and the same meaning. We don't have a problem. So it will be minus a to power nu of n. And we have z to minus 1. So every n will be replaced by n minus 1. And here we have a minus a n minus 1 u of n minus 1. Now, what about the left side sequence? Left side sequence is the inverse will be nx of n. So it will be nx of n, a minus a n to minus 1 u of n minus 1. Of course, the overall will be what? By dividing by n. So it will be x of n minus 1, n to minus 1, a to power n divided by n, u of n minus 1. Really, this example is efficiently utilizes this property. I mean, nx of n will be minus z dx of z by dz. Of course, we have found the dx of z by dz, and then multiply the both sides by z to arrange the left side as minus z dx of z by dz to be nx of n when we are going to perform the inverse transformation. And the right side sequence will be easily determined. Why? It's a shifting, using the shifting property and inspection method, we can determine its inverse. Another important property, which will be the conjugate. For example, if you have a complex signal x conjugate of n, z transformation will be x conjugate and z conjugate. Time reversal. Time reversal, as we have said, we have a reversal when we are talking about left-sided sequences, exactly like this example, x of minus n, z, x of 1 over z. So every z will be replaced by what? By 1 over z. Example, x of n, a to minus n, u of minus n. For the u of a to power n, u of n, we have the following sequence. Okay, so using minus n, it will be minus 1 over minus a z to minus 1. Every z is replaced by 1 over z, and the region of convergence becomes less than 1 over a. Another important property, I'm going to finish up this lecture by this property, is the what? Convolution. Convolution in time will be what? Will be multiplication in z domain. Okay, multiplication in z domain. So let's calculate the convolution of x1, a to power n u of n, x2, u of n. So if you are going to determine the z transformation for these two functions, I mean the convolution, it will be multiplication in z domain. Now it will be x1 of z, 1 over 1 minus a to z to minus 1, ROC, magnitude of z greater than a. x2 of z will be 1 over 1 minus z to minus 1, and ROC will be z greater than 1. So just y of z will be the result of the convolution, and it will be the multiplication between the two signals. Now, this will be the using of what? The using of the property of the convolution. By now, we have y of z. The remaining is what? To simplify this equation and apply the partial expansion fraction to get what? To get the final y of n, which represents the result of the convolution. Okay? Of course, when you talk about the convolution, either you are going to implement the convolution in time domain, or you are going to what? You are going to utilize the property of the z transformation. I mean, finding out the z transformation for the first function, finding out the z transformation for the second function, and then go to the z domain, perform the multiplication between these two functions, simplify them, find out its inverse to get what? To get the final result in y of n. This is about the lecture of today. So in the next week, inshallah, I'm going to complete the other important properties. Of course, we have still a final value and initial value, and we are going to talk about the solution of difference equations using the Z transformation. And in this way, we are going to finish the first part of the DSP principles, and then we are going to move to the fast Fourier transform and the digital filter design. Thank you again, and see you inshallah in the next week.